In the last videos, you guys understood about half-life, average life, all these things, correct? There is one more parameter which is very important for any radioactive substance. That is the activity of a radioactive material. So activity in the sense what? What is the rate of disintegration that is happening per second for that particular substance? See, some of them it's very high, some of them it's very low. For example, if you take polonium, the activity rate is very, very high compared to something like uranium, thorium, all these things, or even uranium and all those things. Uranium takes 24,000 years just to disintegrate half of its radioactive substance. As in, half-life of plutonium is 24,000 years. Uranium to live, uranium is around 10 to the power of 9 years, which is almost the age of this universe. It's very, very high. Okay, now let me start with what is this activity and all those things. So activity is the rate of disintegrations per second. Okay, at what speed the radioactive elements are disintegrating. So mathematically A is equal to lambda into n. So what we have, you'll get A is equal to A naught e to the power minus lambda t. This is the mathematical formula for it. Now guys, in the last video we understood about half-life and all those things, correct? So in half-life and all what we have, and even in activity for that matter, there is a general formula as to how we are going to solve problems. Okay, what we get is A by A naught is equal to N by N naught is equal to 1 by 2 whole power n or 1 by 2 power t divided by t. So let me explain what this is. If you take N by N naught is equal to 1 by 2 whole power n, suppose say after 3 intervals or 4 intervals, you're talking about this. See, half-life, what do you mean by half-life? 1 becomes half, half becomes 1/4, 1/8, 1/16. If you look at it, it's going in terms of 1 by 2 power n, correct? That's the reason we have N by N naught is 1 by 2 whole power n, or A by A naught is 1 by 2 whole power n. Suppose if you are talking about, say I'll tell you that half-life is 5 days. Okay, and after 20 days, how much of material is remaining? So in that situation, we use the last formula, 1 by 2 power t by t. Okay, so this is what we are talking about. Now, when it comes to activity, there should be unit, right? Now, generally, the unit what we use is Curie. See this one, 1 Curie is 3.7 into 10 power 10 decays per second or disintegrations per second. You can call whatever it is. Alright. Now, there is another unit which is becquerel. 1 becquerel is 1 disintegration or 1 decay per second. Or sometimes we use Rutherford. Rutherford is 10 power 6 decay per second. So this is what we mean by activity. Now generally Curie is the unit what we use. In honor of Madame Curie, we use Curie as the SI unit. Okay, like suppose if I say that the activity of a radioactive substance is 2 millicurie. So when you say 2 milli, 3.7 into 10 power 10 into 10 power minus 3 or whatever that particular value is. So many decays or disintegrations will happen every second. Okay, so this is what we mean by activity of a radioactive substance.